Hey, how's it going, everybody? We're going to go over LeetCode question 530, minimum absolute difference in a binary search tree. So you're given the root of a binary search tree, and you have to return the minimum absolute difference between the values of any two different nodes in the tree. So if we just scan this binary search tree, we see that the minimum absolute difference is 1 because you have 2 and 1, absolute value of the difference is 1, and the same for 2 and 3. In this example, it's also 1 because if you look at these two nodes 1 and 0, their absolute difference is 1, and the same for 48 and 49. Okay, so what do we know about a binary search tree? So a binary search tree means that all nodes to the left of a root have values less than the root, and all nodes to the right of a root have values greater than the root. So knowing that, we can actually store the values in order. So if we start at root, first thing we do is go to root.left, and then we go back up to the root. So if we have some array here, we'll just start appending values. First it's 0, then 1. And then you go down to the right, so root.right, and then you scan its left subtree, so root.right.left, and then you add 12. There's no more nodes coming out of this one. Then you go back up to this node, add 48, and finally go back to this right subtree, which is 49. So this is using an in-order traversal. This is how you can get all the values in a binary search tree in sorted order. So knowing this, if we're able to traverse the binary search tree and have it all in sorted order, we can just compare pairs of values and update some global variable called minimum difference. And if we find a pair of values that has a smaller absolute difference than the one we have in our global variable, we update it. If not, then we just keep searching through the array. Okay, so let's just say our min is some maximum integer value, whatever that is. And then our first pairs of values are 0 and 1. That came from these two nodes here. We check if the absolute value of these two are smaller than max. It is, so we update it to this difference, and then we scan the rest. It turns out no other pairs of values are going to be less than 1, so we just keep it the same. Okay, so this is a pretty simple approach, just using an in-order traversal on a binary search tree. So let's code this up. Okay, so we're going to have some global variable called minimum difference, and it's just going to be equal to some very large value. Okay, and then we're going to define a function. Let's just call it DFS, and you're going to pass in the root. Okay, and we also need a variable or a list variable called array, and we're going to add that parameter. We can't forget that. Okay, so this is going to be using an in-order traversal, and the base case we need to consider is if there's no root. So if we get to one of these leaf nodes, then that means there's no recursion that needs to be done. We just return as usual. So if not root, you just return. And the first thing we do is recurse through the left subtree. So we're going to pass in root.left this time, and then the array. And then once we get to this node here, we want to append the value at that root to the array. So you're going to say array.append root.val, and then you're going to call DFS on the right subtree. And from here you can just return. Okay, so at this point we have our list updated with all the values we need. So array should be, the same as before. 0, 1, 12, 48, 49. But we've had to call the function. Okay? And just for debugging purposes, we can just print the array at this point and just return, just to show you that it's working. Okay? So this is the output. As you can see, we're given all these values, but we return it in sorted order. That works just fine. And now that we have our array in sorted order, we need to do the logic to update minimum difference. Okay? So to do this, we need to loop through the array, but not the entire array. We need to get to one position less. The reason why is because we don't want to go out of bounds. We want to compare the value at index I to index I plus 1. So if we get to this point and we try to do I plus 1, we're out of bounds. So we need to stop one position less than the length of the array. Okay? And in Python, to do that, you can just say for I in range, length of the array minus 1. Okay? And from here, you just update minimum difference. So that's going to be equal to the minimum of minimum difference. And then it's going to be array at index I plus 1 minus array at index I. And you don't have to use absolute value in this case because it's in sorted order. So it's a guarantee that the value at I plus 1 is greater than I. If you want to swap these two, then you would have to use absolute value, but in this case, I'm fine with it. And now at this point, you just return the minimum difference. So it's asking you to return the minimum difference. Okay. Let's see if this is working. Okay. Test case is passed. Now let's submit this thing. And there we go. So let's talk about the time and space, all right? Because we're using an array that stores all the values in the binary search tree, that's going to take O of n space. Same with the DFS, that's going to take O of n time. You know, there's no premature exiting the recursion. We have to go through each of the nodes and then compare values. And yeah, that's a pretty simple way of approaching this problem. In a lot of binary search tree problems, you're going to use in-order traversal because knowing that the values are in sorted order, you can do something useful with that information, such as getting the minimum difference or, you know, whatever it might ask you to do. So yeah, that's how you solve LeetCode question 530, minimum absolute difference in a binary search tree. I hope you found this helpful. Thank you.